Mixing in lab-on-chip technology. Mixing of sample with its reagent is an important element in lab-on-chip technology because for getting the results, we have to mix the sample with the reagents to get a positive or a negative result. We know that in a lab-on-chip, there are microchannels and the samples are confined to these microchannels. The Reynolds number is low and the flow is laminar. So there is very little or rather no mixing of the reagent and the sample. The only force which is acting during this process is diffusion. Now, how we can increase the mixing of the lab-on-chip technology? The mixing should be controllable and fast. There are two approaches which are used for mixing the reagents with its sample. One approach is a passive mixing and the other approach is an active mixing. Passive mixing में हम अपनी माइक्रो चैनल्स को इस तरह डिजाइन करते हैं कि it increases or facilitate the mixing of the reagents with its sample without any external force. While in case of external active mixing, we use external forces, and these forces could be used by using certain types of micro devices. अच्छा, अब पैसिव माइक्रोफ्लूइडिक मिक्सिंग में हमें इस बात का ख्याल रखना चाहिए कि हम जो भी स्ट्रेटजी यूज करें, इट शुड बी कंट्रोलेबल एंड फास्ट. आमतौर पे इस पैसिव मिक्सिंग में हम दो अप्रोचेस यूज करते हैं. पहली अप्रोच तो ये है कि माइक्रो चैनल्स में कुछ वेल्स प्रोड्यूस कर दिए जाएं and they will increase the movement of the fluid. The other is that we can use a multi-channel strategy, यानी कि सैंपल को एक के बजाय दो या तीन जगह से इंट्रोड्यूस कराया जाए ताकि इसका कॉन्टैक्ट टाइम और कॉन्टैक्ट एरिया दोनों बढ़ सकें. इसमें मैं आपको एक एग्जांपल बताऊंगी जिसमें we can use a different geometry. For example, we can use a T-shaped माइक्रो मिक्सर और वी कैन यूज अ वाई शेप माइक्रो मिक्सर. आमतौर पे ये दो तरह के माइक्रो मिक्सर इस्तेमाल होते हैं, लेकिन मैं सिर्फ टी माइक्रो मिक्सर की यहाँ पे आपको एग्जांपल दूंगी. अगर आप टी शेप को जहन में इमेजिन करें तो देयर आर 2 इनलेट्स एंड 1 आउटलेट, यानी कि सैंपल दो जगह से एंटर हो सकता है एंड दे कैन ट्रेवल पैरेलल टू each other, or they can enter perpendicular to each other and then they can travel parallel to each other and later they can mix. Maximum efficiency हासिल करने के लिए हम इन channels में कुछ barriers या obstacles भी लगा सकते हैं. These barriers or obstacles could increase the mobility of the sample and thus increase the movement of the sample. You can see in this slide that in a T-shaped micromixer, there are 2 inlets. At one end, they are shown in red and green. We can introduce the sample at these 2 points. They can meet at the center and then they will travel. And by doing so, we can increase the efficiency or the mixing of the reagents with the samples. In another approach, as I have told you earlier, we can use different geometrical structures. Say you can see, we can use a zigzag shape, we can use an S shape, or we can use different V-shaped protuberance, and that they could help the mixing of the reagents. अब पैसिव मेथड्स के बाद हम एक्टिव माइक्रोफ्लूइड मिक्सर की तरफ आते हैं. एक्टिव माइक्रोफ्लूइड मिक्सर में हम फिजिकल फोर्सेस का इस्तेमाल करते हैं. And these forces which are used in lab-on-chip technology involve acoustic wave, pressure perturbation, magnetic field, change in temperature, or use of ultrasound waves and fluctuation of electric fields. इन forces को हम इस्तेमाल करके samples को mix कर सकते हैं. How does it work? मैंने जैसे कि आपको पहले बताया कि एक्टिव माइक्रोफ्लूइड रेफर्स टू द डिफाइंड मैनिपुलेशन, यानी कि जो भी हम स्ट्रेटजी यूज करें इट शुड बी डिफाइंड एंड इट शुड बी कंट्रोलेबल. वी यूज माइक्रो कंपोनेंट्स एंड दीज माइक्रो कंपोनेंट्स आर यूज्ड फॉर द continuous और dose supply of the reagent or sample, यानी कि या तो मुसलसल हमारा reagent सप्लाई किया जा सकता है या उसको डोज फॉर्म में whenever it is required the drop or the dose of the reagent or sample is provided. दूसरे केस में माइक्रो वेल्व बेसिकली डिटरमिन्स द फ्लो डायरेक्शन कि हमारा रिएजेंट या सैंपल किस डायरेक्शन में जाएगा और उसकी मोड ऑफ मूवमेंट या स्पीड क्या होगी. You can see in this slide, this is a lab on chip for the PCR technology. Here you can see this slide is very elaborating, but we will only concentrate on the first two things, that is the flow driver and the flow controller. And these flow drivers and flow controllers are very helpful in driving the samples and reagents to mix together, and that could provide the result later on. Now, in summary, mixing of reagent and sample is an important, or rather a most important thing in the lab on chip technology. There are two approaches for mixing the reagents with its sample. First is a passive approach. The second is an active approach. In passive approach, what we can do is we can use special designs to introduce the to increase the sample mixing, and or we can use different geometrical designs. In active mixing, we can use different active microfluidic micro devices such as valve and pumps. Mixing of reagents in lab on chip technology is very important for increasing or for the better performance of a lab on chip system.